All right, so we are looking at dilations here, guys. And with dilations, we have done some stuff with them before. In this case, I don't know if that makes it better or worse. Worse. Okay, awesome. I could hold it like this. I don't think I can do this the whole time. All right. There we go. Okay, so we're dilating this by a factor of 3. So you need a ruler. You need a ruler where you can take measurements. We are going to look. Do you guys see that this part right here is in inches, the top? Okay, you want to use the other part. It says mm. Millimeters are the little tiny ones. The whole thing, that's a centimeter. Okay, so we're going to measure this in centimeters. The first thing we're going to do is we're going to connect A to B. You see this point A right here? We're going to find the length from A to B, and then we're going to make that 3 times as big. Okay, that's our dilation. So the first thing I'm going to do is draw a straight line between A and B, and then after I draw it, I'm going to measure it. Okay, A to B is, and I'm going to show you multiple ways to do this. We can also do this with a compass. This is 1, 2, 3.5 centimeters. Okay? Now, this part seems a little strange. We want it to be 3 times as big. So 3.5 times 3 is what? Okay, you have calculators in front of you, but it is 10.5. Okay? Now, 3.5 times 3 is 10.5. Now, shh, I'm teaching over here. Okay. Now, this is where it gets a little weird. I have a lot of people mess this part up. We want it to be 10.5 from A. So we don't start measuring from B and go 10.5 up. We start from A. So at A, I want to go to 10.5. So this way up here, that's my new B. And that's 10.5. How are we doing? The problem when I zoom in is it doesn't all show up on one paper. You can also do this with a compass. I like it better with the ruler. Okay, and most of you have rulers at home if you need it. Now we're going to measure, we're going to draw a line from A to C, and then we're going to measure that distance, A to C. Okay, so A to C is I've got 2, I'm going to say 2, because it's easier. Okay, what's 2 times 3, guys? 6. So I'm going to go from A past C, I'm going to go to 6. Now remember, it's always we're measuring from A. We don't put the end at C. We put it at A. And there, this green part, that's 6. Okay. So far, so good? Yeah, I can slow down. Sure. All right, you guys are good with you draw A to whatever point you're going to do, and you measure that, and then you times that by whatever you're dilating. Okay. All right. I want you to notice, excuse me. Yes, Madison? Yep, we should put C image. Okay, when we're doing positive, we go up and to the right. What do you think's going to happen when we do negative? Down, it goes down. What happens if we times it by, instead of a whole number, by a half number, by like a fraction? Is it going to be just as big? It's going to get smaller. Good. Good. Okay. I'm going to draw a line now from A to D. And I'm going to measure it. A to D is, let's say, 4.5. Okay? And so if we take 4.5 times 3, 13.5. So now remember, I'm doing it from A, not from D. Everybody wants to do it from D on the test and everything. Don't do that. We want 13.5. So I'm going to go all the way to 13.5 right here. That's my new D. Okay, we're going to do one more step, and then we're going to do a check. Okay, and then this problem is done, and then you guys can do the other ones on your own. So, my last step, are you guys ready, or you need a minute? One more second? Yep. Good. Okay, I'm just going to connect B to C. I'm going to connect C to D. And I'm going to connect D to B. So see, I have a bigger triangle. It's 3 times as big. How do I know this? You can measure. If we look, C to D is 2.5. So if I take 2.5 and times it by 3, my new C to D should be 5.5. So when I measure from here to here, this C to D is 2.5. Oh, I did plus 3. 2.5 times 3 is 7.5. So this should be 7.5. Which is about what I got. So it's 3 times as big. Okay, so I'm just going to quickly talk about each page, but not actually do it. This is, excuse me, this is negative 2.5, so it should go down. It should go this way. It will still be large. It will still be bigger of it. It'll just go this way. So you're going to measure this, and then from here you're going to measure it. Okay? Should we do one? Just one side? Okay. So A to B is 2.5. 2.5 times 2.5 is 6.25. So I'm going to make this go in the same direction, but it is 6.25 away. So it is, okay, I'm measuring it again. You're right, I get 3.5 too. So this is 3.5. Thank you. 3.5. Now I'm going to make it so it is 8.75 away. But I'm going to line it up so it's going the same direction. 8.75. So my new B should be way down here. Because it's negative, should we go down? And it's my distance from A. Not from B, but from A. It's negative, so it goes down and to the left. Okay. Number 3 is a factor of 0.5, so this triangle should get what? So number 3, it's a factor of 0.5, so this triangle should be what? Smaller, so it'll be down here. it'll be underneath it, smaller. And the last one you're going to do on your own, you're going to make your own shape and your own center of dilation. That's that A. And you're going to dilate by any negative factor of your choosing. And you're going to show it on this page. Okay? Your homework for tonight is all about trapezoids. Trapezoids have 4 sides, exactly 1 pair of parallel sides. The median is parallel to the base. The median has a length equal to the average of the bases. A trapezoid with congruent legs, opposite angles are supplementary, as an isosceles one. So this says the median has a length equal to the average of the bases. So for number 1 right here, you would say x minus 3 plus 2x minus 4, this whole thing together, divided by 2 equals 10. Average means you add them together and you divide it by 2. Averages means you add it together and divide it by 2. And you take the top and the bottom, that's the bases, that's what it says right here. Divide it by 2 and you get the median, the middle. Okay? I recommend that you do the dilation activity in class. You've got rulers. You won't forget how to do it. This you can do at home. It gives you some explanation of how to do a trapezoid. Okay? All right, I am stopping the recording.